Welcome to DWBIADDA channel. Please subscribe for latest training videos.
Hello everyone, welcome back to the playlist on computer vision. In the last lecture, we saw about blurring an image using OpenCV, and previous to that, we also learned about color spaces. So I hope the concepts of color space and blurring is now absolutely clear to you and you're comfortable working with it. We will now take the concepts of OpenCV into an advanced level. But like before moving ahead, I would like to talk about the bitwise operations in OpenCV. The future agendas actually for some of our upcoming lectures will be a complete revision of all of the concepts that we have actually learned, starting from NumPy to OpenCV, along with some real life examples and hands-on coding, which will give you a complete A to Z understanding of what's happening in OpenCV and how to use all of these functions in a combined. But before moving ahead with all of these topics, let us set the agenda for today's lecture, which is all about bitwise operations in OpenCV. So I hope you all know about bitwise operations and logical gates. So there are four bitwise operations that are available to us in OpenCV, which are the OR gate, the AND gate, the NOR gate, and the NOT gate and the XOR gate. So these are the four basic gates that are available to us, and I also hope like you remember like how the input and output for these gates functions. So to give you a brief recap, like if you're having an OR gate and if you're having an input as one in any of the inputs, so the output will always be 1. Similarly for AND gate, if you have a 0 anywhere in the input, the output will always be 0, otherwise the output will be 1. So this is how like bitwise operators actually perform in real life, and we will actually extend this concept to OpenCV as well. So what I will do is I will quickly go up and fire up my Jupyter notebook to give you a complete understanding of the bitwise operations in OpenCV. So what I will do is I will import OpenCV as CV2, and I will also import NumPy. After that, uh, okay, so while explaining the concepts of bitwise operation, I will be only using an image with two colors, that is black and white, so that it's actually easier for me to explain you the concepts of bitwise operations. However, we'll extend these concepts onto the color images as well. You don't need to worry about this, but at this particular point in time, we're only concerned about black and white images. So let's say I want to create a complete black image using NumPy and OpenCV. Can you actually do that? I hope you remember to create a complete black image using NumPy. What you have to do is you have to call np.zeros, as zeros is like as the value will be 0 for all pixels, and now you actually have to give the size for the image. So let's say the size for the image is 800 cross 1200 cross 3, right? So we'll just run this piece of code over here, and it's zeros actually, something like this, and this will actually create a complete black image for me. In case you're interested to see how this image actually looks like, you can actually call cv2.im show image1, call in x. Similarly, you will actually have to call cv2.wait 0 and cv2.destroy all windows, something like this. And as you can see, a complete black image has now appeared on screen for me, right? So now let's say you want to draw a rectangle, a white rectangle over this black image. Can you do that using OpenCV? Obviously you can. You just have to call the cv2.rectangle function, and you have to give x as the source image. You have to give the starting point and the ending point. Let's say the starting point is 100 comma 100 and the ending point is 400 cross 400, and let's say you have to create a white color rectangle. So for it, the color space will be 255 comma 255 comma 255, and I want it to be a thickness of -1. Let's see how this image actually looks like when you have actually drawn a rectangle over the complete black image. So this is how the image actually looks like. Similarly, now let's say I want to have a Y image with the same style, but it will be a complete black image, and there will be a white rectangle as well, but there will be a slight change in the starting and ending points of the rectangle. So what I will do is I will go ahead and copy this piece of code. I will change it to Y over here. After that, what I will do is I will copy this piece of code over here, and I will change it to Y over here as well. I will also change the coordinates. So cv2 rectangle, let's say the coordinates is 180 comma 180, and it's 640 cross 640, and I will let the color and thickness remain the same. This is how our this is how we will have a black image with a white rectangle on it, and we have named this image as Y. So in case you are interested in having a look at the Y image, I will give you a feel as well. So let's say this is Y, and I will change this name to image 2, and this is how the Y image will actually look like. Fine. Let's say now I want to do a bitwise AND operation on image 1 and image 2. So what do you actually expect in output? So what I will try is I will actually open both, like all of the three images simultaneously, that is input output, like x y, that is both the inputs and the outputs, so that you can have a good understanding. But before that, let me call this as z, the bitwise AND operations of these images. cv2 dot bitwise AND is a function in which I have to give two arguments. The first argument is x and the second argument is y, and I will be passing it on to z here. Something like this. And now let's say I want to open the image one, which is the x image. Then I also want to open the y image, which is the image two. And I also want to open the z image, which is the bitwise and of these images. Something like this. And I will run this piece of code, and this is the image one. Okay, so currently only image one is opening. So have a look at image one. I hope you already know about image one. uh, this is the image two. Like, this is a bigger rectangle or a bigger square, as you can see, and this is supposed to be my image three. So this is actually image three. So I will run this for you again so as to give you an example or a complete understanding. So let's say this is my image one. Image one, we have something like this. Have a look over here. In image 2, we have a bigger rectangle, something like this, and then this is the image 3 that we got after having a bitwise AND operation. So what do you think how the bitwise AND operation actually perform? So actually what happened is that we actually considered that all black images are 0 and all white images are actually 1. So wherever there was a intersection of 1 and 0, that is black and white, the region actually turned into black because 0 dominates over 1 in an AND operation. And at the same time, like let's say uh, you are having like a white region and a white region, that is both are one, so that region actually turned into white because the operation or the AND operation will always give you the result as one. So in case you are wondering like how these look like again, so I will just run this code for you. So this is the image one. See, it's slightly shifted on the left, and image 2 will be something starting from here, so like something starting from here, and image 3 will actually lie somewhere over here. So this is image 1, this is image 2, and see, this is image 3. So only the white intersection part, like the intersection part, you can see where the white part was actually intersecting, is what you are getting as an operation to the bitwise AND operation on OpenCV images. So this is all about like the AND operation and bitwise operation in OpenCV. In the next lecture, we'll be discussing about the or bitwise operation in OpenCV. I hope you like this video lecture, and you have learned something important, interesting from it. Till then, stay tuned. Thank you.